There's a lot of misinformation out there when it comes to LUTs. A large portion of the people trying to sell you LUTs have a poor grasp on their design, and their ignorance can cause a lot of headaches on your projects. To solve this, I've got a number of videos in the works to help us with this topic, and today we're going to start with getting a rock-solid understanding of what a LUT can and can't do. Before we get too far though, a fair question is, well, what is a LUT? Well, here's a working definition for a LUT or lookup table. A LUT is a fixed list of numerical values used to transform an image color and or contrast without user input. That's it. Under all the discussion of contrast curves and film print emulation, hue adjustments, a LUT essentially looks at a pixel that comes in, applies an adjustment based on its code, and kicks the pixel out the other side. It's not looking at the pixels next to it, it's not doing any time-based evaluation, it's just pixel in, apply some math, and pixel out. The way this was first taught to me was by opening up a very simple 1D LUT. Now, while there are many tools to work with LUTs, Lattice is one of those tools where it simplifies a lot of the process. That said, you don't need Lattice to understand LUTs. In fact, some of the videos that I have working in the future will show you some alternatives to that. It's just helpful for this example. So here we have Lattice, and I am going to create a new LUT for us. And this is going to be a very simple LUT. We're just going to pick a 1D LUT, and we're actually going to make it only a 3-point LUT, just so that it's incredibly simple. So I'm going to hit Create. Now if I click on over to the curves, you'll see that this 3-point LUT has, well, 3 points to it. 1 point representing the black, 1 point in the middle, and 1 at the top with white. If we were to try to apply this to some footage, you'd see that there's no real change going on. The pixels that come in are being sent out in the exact same way. There's no modification. What I'm going to do now is save this LUT so we can open it up in a different way. You can open up a LUT with any plain text editor, but the one that was recommended to me was Sublime Text, so that's the one I'm going to use. So look at this. Inside of our LUT, we know it's a 3-point LUT, and here are our 3 points right here. So we have the black, we have the middle, and then the white point. And these numbers are representing output values. We don't need to list the input values because a LUT implicitly understands that a 3-point LUT, the points are distributed in this way. You'll also notice that there's 3 columns. So these columns represent red, green, and blue. And we can actually tweak some of the numbers in here. This isn't how you necessarily normally build a LUT, but watch this. Let's say we want a little more in our red channel in that second point. So instead of 0.5, maybe we say 0.75. Red and then green is the next category. Let's say we'd lower the green by a little bit. So let's say it's like 0.4. Let's say we lower the blue by a lot. So maybe like 0.2. Well, we can save this, and what I want to do is I want us to open this up in Lattice and see what the result is. When we open this up, we can now see the changes that we've made. So we didn't adjust the first point or the last point, but you can see in the middle we've edited these points. And if I kind of hover my mouse over the center here, at the bottom of the screen, you'll see the input values and the output values. So over here, you'll see that the bottom says, if I can get it right on 0.5, so right about 0.5, 0.5, 0.5, it's coming out as the red is 0.75, the green is 0.4, and the blue is 0.2, just like we adjusted the code. Something else that you'll observe is any values between the points are being interpolated. Simply, they're just drawing a line between them. It's not like there's a spike at the one point we made an adjustment. We're drawing conclusions on, let's say something comes in around the 0.25 mark. Well, it's going to be adjusted approximately between these two. LUTs inherently have some estimation going on inside of them. You may have heard of a 33-point LUT or a 65-point LUT. What that's referring to is the number of points on this curve. And adding points can be helpful to generate some smoothness to the curves. Let me open up for us the default film print emulation in Resolve, and you'll see that it is a 33-point LUT, and because there are 33 points, even though the lines are being drawn straight between them, we do get this nice curve effect. And a 65-point LUT can add even more detail and control to the curves. Now it's worth adding that adding an infinite number of points to a LUT doesn't necessarily make it any better. If you were to use hundreds of points or thousands of points, it really wouldn't improve our lives anymore because first of all, it would be incredibly computationally difficult for our systems to handle. But second, at a certain point, you're just going to be creating noise because there are maybe minor inaccuracies in how things are set up. We want enough points to provide smooth curves, but beyond a 65-point LUT, we often don't see much value. This leads us into probably the most essential piece of this entire discussion: what LUTs can and can't do. Let's start with what LUTs can do. Now, there are three main categories of capability. First is a technical transformation of the contrast and/or color, often referred to as a technical LUT. You may have used these before without even realizing that that's what they were called. For example, if you have a camera manufacturer who has a camera that records in a log profile, they may also supply a LUT to get you from that log state to a normalized image. So here's a sample image from an ARRI 35 camera, and we know that ARRI provides a LUT to get us from the log state into a normalized state, and we might call that a technical LUT, which is right here. So if I enable it, we go from a log image to a normalized image. That's targeting Rec. 709. As I turn the LUT on and off, you'll see that we're not trying to impart some sort of creative vision for the project. We're just trying to take the known log state and transform it into something normalized for our screen. The second category is LUTs can have a creative transformation of the contrast and/or color. These are often referred to as creative LUTs. These LUTs are specifically designed to give us preferential changes to the image without making adjustments to the color space. In this example, I've set up some basic color management to go from ARRI's log to DaVinci Wide Gamut and DaVinci Wide Gamut to Rec. 709. Now, this color management is not something I'm going to talk about in this video, but it is something I've discussed previously, so go make sure to check out those videos. As I enable and disable this creative LUT, watch what happens. We enable it, and you'll notice that these are preferential creative treatments, not technical transformations. So we're getting a little more saturation in some of the skin tone and orange parts of the image. Maybe the blues are getting a bit more saturated. The magenta isn't really moving around. We can see that on the vector scope down here. This is a creative adjustment that's not making a technical transformation of the image. If I disable everything and just try to enable this LUT, you'll see that there's a little bit going on in the background, maybe some additional contrast adjustments. But this isn't taking a log image and making it standardized. Finally, you can combine these two functions to create a hybrid LUT. This is a LUT that takes both creative choices and technical transformations and puts them together for your footage. A great example of a hybrid LUT is one of the film print emulations built into Resolve. So I'm just using, this Kodak 2383 D65. So if I enable it, you'll notice there are creative choices being made, but there's also a technical transformation from ARRI's log state into Rec. 709. Or I should actually say that LUT expects Cineon in. So I've set up a little color space transformation to go from ARRI to Cineon there. Once again, that's color management. I discussed that in other videos. But for now, realize that the hybrid LUT is taking the flat image in and kicking out a Rec. 709 image along with creative transformations that hopefully we like. Hybrid LUTs are also very helpful when exporting a show LUT for on-set work. While we may have certain creative choices we're making in the look development, those creative choices will need to be coupled with a transformation to ensure the log footage the camera is recording is viewed properly as a normalized image on the monitors and screens. So if that is what LUTs can do, let's pivot to look at what LUTs cannot do. First and foremost, LUTs cannot adapt for a different color space. Every LUT has an expected input and output, and if you don't know this information or feed it the wrong information, it will not work correctly. Let's take an example from outside of filmmaking. If I wanted to convert a temperature from 50 degrees Fahrenheit to Celsius, I could use a conversion calculator, but what happens if I don't care about the information that I'm feeding it? Let's say I just open a calculator and type in 50 degrees. Well, the number on the bottom says 122, so it must be 122 degrees Celsius, right? Wrong! Do you see how silly this is? If I feed it the wrong information, it will never work properly. When we feed it the correct information, we get correct results. To further this example, let's say that I just indiscriminately drop a LUT on this footage. Well, I wasn't paying attention to the inputs and outputs, and of course I'm gonna get garbage results. There's two things to learn from this. One, don't expect to get good results if you're not paying attention to the inputs and outputs that a LUT is demanding. Second, if a LUT doesn't provide you with its input and output information, don't trust that LUT. First of all, it's probably going to be garbage. And second, don't trust that creator because they probably don't know what they're doing. Second, LUTs can't accept user input to change their behavior. This is one of the biggest reasons why many colorists get frustrated with bad LUTs. If a LUT does things you both like and dislike, there's no simple way to extract only the specific pleasing elements and leave the rest. Sometimes you can duct tape together a solution, but it's never an ideal situation. The flip side of this point is that sometimes that black box nature of a LUT is actually the appeal to some users, because if it doesn't require user input, well, if you like the results, you don't have to do anything more, assuming it serves your creative vision. The next thing a LUT can't do is spatial or positional operations. Think about power windows. Now that you've seen the inside of a LUT, you know that a LUT can't add a vignette because it doesn't know anything about your frame size. It's just pixel in, pixel out. You can't adjust the aspect ratio of an image. There's no letterboxing that can be added. Anything that would require spatial knowledge of the frame, it can't do. Fourth, it can't perform textural operations. Think film grain or glowing, halation, noise reduction, sharpening, softening. When you use a film print emulation LUT, it's not going to be adding any sort of film grain, gate weave, or spatial texture. It just affects color and contrast. And finally, LUTs can't perform any sort of analysis-driven operations like auto white balancing. It's not going to be observing your shot as a whole and making subjective calls about where the white balance should be, or the auto exposure, where that should sit throughout the shot. If you want a cheat sheet to remember what LUTs can and can't do, you can download it from my resource link in the description. So there you go. At this point, we've looked at what a LUT is in its simplest form, and now you understand what they can and can't do. I have some future content cooking up about some advanced LUT analysis techniques, but for now, what questions do you have? I'll keep an eye on the comments section, and if helpful, I can produce some follow-up videos answering those questions. To stay up to date on that content, make sure to subscribe, and if you found this video helpful, would you share it with another artist who would benefit from it? All right, hit that like button to feed the algorithm, and I'll see you in the next one.